This project I have in front of me is a power amplifier. It is by Harman Kardon. It's the Citation 12, and it is a stereophonic power amplifier. This kind of equipment is new to me in terms of its design and its purpose. So this would be what would be driving your speakers in a stereo system. This is just an amplifier. There's no mixing or anything that happens on here. You give it a signal in either the left or right, and then you hook up your speakers here. This particular unit is probably, I'd say, early 70s. And I received this, actually I received two of these, and this was labeled as being a parts amp. And if you repair RCA jack, switchboard, easy to do, and fuses, it might be the better amp. The other one is identical, same model, and apparently works, but I haven't tested it. But with this one being broken, I was eager to dive into it and see if I could get it fixed. And since I have two of them, I named this one Hot Potato because, we'll see once we open up some of the issues that it's having. Well, actually, before I do that, we'll just do a little close-up on some of the conditions here. One thing I've been really wanting to do from the get-go is clean it, but I didn't want to do that until I kind of dove into this project with using, capturing it on video. There's quite a bit of dust down in between these heat dissipating fins, and yeah, I really want to get that cleaned out. And then between our connections up front here, there's a lot of buildup, a lot of dust. And the RCA jacks, I'm not certain if there's really anything wrong with them other than the fact that maybe a little corrosion, a little oxidation on the metal surfaces. Alright, so let's open this thing up. So in order to get the cover off and to see inside, you got to put this unit upside down, and the bottom plate has to be first removed. And it looks like there's we have missing screws here, but there's screws in one of each corner. So they're about 1/4 inch. So I'm using a 1/4 inch nut driver to remove those. So here's the guts underneath. Just taking a look here, take a little tour. So the way this amplifier is set up is, I believe it's called a dual mono block or a dual mono amp, where it's essentially two isolated circuits altogether. They have their own power transformer, their own power supply caps, and all that's devoted for the one channel, and then a complete copy of that for the second channel. These caps right here are electrolytics. Those are for the inputs. They come right off the RCA jacks, and they go to these underside of these pins, which are on the top side, how the one circuit board in this thing connects with all these connections underneath here. But these are 6,000 microfarad electrolytic power supply caps. They're Mallory's. They have their own bridge rectifier for each circuit. And so from what I read, that by doing this, it just gives ample power for each system instead of splitting the power supply to power two different channels. And this allows, I guess, a lot more supply of oomph for loud and low frequencies and whatnot. I like the ground bus bar, the way that they have that set up. Oh yeah, so one issue that is in this area that we can get a look at too is there's a 10 ohm carbon comp resistor that has melted. It's completely in half. The wire you can see melted. This was connecting the ground on this channel to the chassis ground, isolating it, where this channel, it goes straight from here to the chassis. So I guess that's their method of isolating it to some degree. So you have two different ground paths. Each circuit has its very own. But that being blown, I guess a short somewhere in that circuit and caused a lot of current to be going through the ground and just cook this 10 ohm. This is a 1/2 watt resistor. So to take this top cover off, you have to remove screws in here. I believe it is this screw, and this screw, and this screw. Okay, so these are the one right here and one was right here. That's a issue. Here's the circuit board, and there's the pins from the underside, and they connect into these sockets. I'm just going to take that out and lay that down. So taking a look at here's the top side, and here's the transformers. We have our filter supply caps, the Mallory's, the 6,000 microfarad, 50 volts DC. Yeah, not a whole lot it's a very simple, straightforward design. There's these two things right here, which are they're dusty looking. They look like Christmas tree light bulbs. These apparently are in series right before they go to the positive terminal. And here we have 1, 2, which is underneath of this thing right here is a thermal cutoff, and they're mounted on top of these transistors. But you have 1, 2, 3, and 4, and all 4 are the same transistor. These are the power transistors. They're RCA 4216. Being that this is from the early 70s, of course, those are not parts that are just stock parts. You can just they're abundant and easy to get. I was looking online to try to find equivalents, and it was quite a procedure in terms of having to try to find data sheets on these original transistors, and then take the specs from that and find a equivalent that would fit. This circuit board is the exact same thing twice, right channel, left channel, and they have it laid out in a mirror. But yeah, it's nice because if you have a problem on one side and the other side's still good, you can use the working side as a reference. But down inside here, let's see if I can get it to focus, you have a resistor that has completely just melted, burnt, smoked. You can see all the blackening above it. That is a 10 ohm, but this is a 1 watt carbon comp resistor. And there it is on the other side, not burnt up. There it is, all burnt up. Any other issues that stand out to me on here? Nothing else is burnt. However, I did notice on this side we have a transistor that has 6 legs to it, but 3 of them are cut, and then this transistor has been installed. And on the opposite side, it's just one can, and it has 6 legs coming out of it. And the what this is it's basically 2 transistors in one package, and they are matched, and it's set up for a differential amplifier for the input. The input comes in, and essentially that's the first bit of silicon that they hit. So over here we've got a I don't know if one side failed, and so this was put in to make up for it. But another thing that stood out to me that was different is that This is RCA 4219. This is an RCA 4218. Over here we have the RCA 4219, but then this one does not have any labeling on it, and so I assume that this was done aftermarket. I haven't tested to see if this thing has any sort of shorts on it, or any sort of DC voltage on the speaker outputs. The only testing I've really done on it so far was with the board here removed. I powered it up, and I found that the power supply on both sides was delivering the positive and negative rails right on spec with what they're supposed to be putting out, which was about a little over 40, like 41.5 volts, negative and positive. So both sides are good for the power supply. So then I took a multimeter and put it in the diode testing mode and started doing checks on things, and we had a couple bad, basically on this channel I had a couple transistors with shorts between the emitter and collector, or the collector and the base. So I believe it was this 4219, which, let me get my schematic out. Okay, so I highlighted the transistors that had shorts, dead shorts on them, and we have this one right here, the 4219. That's a driver transistor. So that one right there had a dead short. The other one was this 3221. This is a bias transistor, and I believe that was this one right up here with the plastic package. And then the other two that were dead shorts were the driver, or the output transistors, which is this one right here, the RCA 4216, and this one right here, which is also RCA 4216. Yeah, the base was shorted to the collector on this one, and the emitter was shorted to the collector on this one. So I went through and tried to find replacement equivalents for all the transistors in this circuit. This one, instead of like a 2 unit, I just looked for a transistor type that I could put 2 in and put them close together and test them and try to match them to make a good pair. But my goal is to replace all the burnt resistors, and then the transistors that are failed I want to replace. And I think what I'm going to do is actually just remove all the transistors on this board and put them with newer equivalents that had close to matching specs. I'm also going to replace this, and this. These are all electrolytics. This one, and this one are all 50 microfarad at 50 volts, and this one's 250 microfarads at, 6 volts. So since those are electrolytics, they seem to be, they had tested fine with them being in circuit, the best I could do. It seemed like they were good, but I'm going to replace those as well. And I bought 4 of this style transistor to upgrade the units here. Now, 2 of them being shorted aren't any good, but the 2 that are good, I will mark and put those in stock. And same thing with the rest of this, the rest of these transistors. I'll do test on them and then put them into, just save them as they're being working ones, and the failed ones I'll put to the side. The only other, I think, thing that's has an issue are these pieces right here. And we have, here's where it mounts to, and we have one over here. Both of them have been broken and have been attempted to be repaired with glue, and they're not in the best of condition. And if I had a 3D printer, man, that would be like perfect for a solution here. Just lay them out, and I don't know how you do all that stuff, but just design a new one, just like print a brand new bracket. But I don't have one of those, so what I'm going to be doing is taking these off, taking the legs, the parts that have broken, trying to do a repair on these to reinstall them and have them serve their function as they did before. I think the next thing for me is taking some compressed air and just cleaning this thing out. Wipe this stuff off. But I did do a little test where up in this corner I used a little bit of acetone on a Q-tip. But as you can see around the border, there seems to be this like brown sort of yuck. And there's a lot of that. I don't know, maybe that's rosin from solder. I don't know. And then the underside here, also pretty yucky. So some Q-tip action. But yeah, some things noticed on here. Let's take a look at it. So the resistor that was burnt up, I believe, is the connections to that on the back side are right here. Take a look at the trace. The trace for that got so hot it burnt up and lifted off the board, toasted. So that's got to do a repair on that. That comes down, ties into this tab. So we'll have to make a jumper, fix that up. You can see there's been some rework here. I mean, the coloration of the solder and everything makes it look like someone was working around there, but you can really see a lot of rework over on this side. That one transistor that didn't have any writing on the top, that's this one right here. Looks like they're having some difficulty with, they lost some of the pads. They had to put in some, they used the legs to get over to the, scratched away some of that coating to get to the copper and then soldered to that. Over here we've got a trace that has been redone with a piece of wire. And up here you can see a lot of this muck. Yeah, it looks like there's already been some aftermarket work or someone else in here working, but yeah, I like to get all this cleaned up and just tidy it up. But yeah, the next step, I think we're going to have to get the compressed air out and blow a lot of this off. Most of that soiling is just right up in here, down in these fins, and then because of the cover having these having this vent here, a lot of dust had built up in this area. So I want to get that cleaned out next. Alright, so I brought this unit outside to spray some compressed air on it. Alright, so we're back on the bench. Now that I've blown out all that old DNA, all that fuzz, excited to kind of start getting more into the nitty-gritty of this project. I don't know if I had mentioned it, I did testing on these with, I'll show you. Granted, I had them in circuit, and also I used this thing, and also just used a digital multimeter, and from the results that I got, these caps did not seem to be bad. And then when I had hooked it up without the circuit board in there and tested the voltages coming off of these caps, I was getting voltages like as they have on the schematic, negative 41.5 and positive 41.5 DC. So I'm not really too eager to spend the money and replace these caps right off the bat, but all the electrolytics that were in circuit they weren't very much, so those will all be replaced. The disc caps, like ceramics, I'm not gonna fool with those, and the diodes didn't seem to be testing as failed, at least at the initial stages of diagnosing. The other thing I don't think I mentioned was that it does need new fuses, but initially there was no fuses in either one of these holders, and I didn't have 3 amps on hand, but I had 1 amp and they're fast blow, but the manual I believe calls for 3 amp slow blow. So I ordered some 3 amp slow blow fuses, and with the 1 amp fast blow, just hooking this up again without the circuit board, so it's basically just powering up the power supply circuit and feeding those rails going to these pins to feed the circuit board. Didn't have any issues with these blowing up, so it seemed like whatever the issue was causing the catastrophe with this thing was happening on this board itself. Probably a failed component that led to a short, and current got carried away and cooked up some stuff. And I use a parts organizer to keep things separate and so I don't lose screws and such. Got that to the side here. I'm waiting on a parts order that I put in with Mauser. So I suppose in the meantime though, I'm going to put a little bit of work on, maybe I'll clean this board up, get out some Q-tips and some acetone, try to remove a lot of the this residue that's aged and hardened around it. I've cleaned to my best ability the surface area that was exposed, and then I decided to remove all the parts that were going to be replaced. And I'm focusing on the left channel, and I'm not removing anything from the right channel. In the process of testing out the work I do to the left channel, if the right channel is functional, I'll use that as a comparison. But ultimately, if everything goes as planned and the left channel ends up working as I want it to, I want to go through and replace all the same parts on the right channel as well. Now, I went and cleaned things with just a little bit of vinegar and a cloth, wiped things down, just kind of took the dust off, and ended up removing the power transistors from the left channel, and I had those in here, and I'm just using my parts bin to keep everything organized. So I believe the next step would be trying to come up with a repair solution for those plastic brackets that keep the circuit board snug down onto their connecting pins. This one, it's just the feet have broken off, and on this one the foot's broken off on just one side, and it looks like, yeah, that side's still good, but the top broke there, so that'll be needing to be repaired. They're not glued up in a way where it's a level like the other one is. I'm thinking about super glue, maybe a little this stuff. I was able to take these two brackets, and back here I was actually able to scratch off. It just peeled off all the old glue that was on all the broken points on these two brackets. All the broken points I put back together, and I just used a little bit of super glue, which is, I have no faith in its strength, for keeping these things sturdy and rigid and keeping up with the job that they have to do. I got some plastic here out of the recycling bin. It was actually a greenies bin, a plastic bin, and this plastic is 0.7 millimeters thick. It's fairly thick. It wasn't too easy to cut with just an X-Acto knife, but I took and I made some brackets essentially to reinforce these pieces. So I made sort of like a piece here, and what I'm going to do is put that over top of the bracket like that, and I want to use some of this stuff right here. I've had good success with this. Very strong bond, and has some flexibility to it, unlike, say, this stuff, which is very brittle. So I was going to glue these to the one side on the top, and then I also, well, that shows you the strength of the super glue. Bummer. I'll re-tack that. And then I also made these what looks like the letter H's, and these will slide onto the feet. I'll put these on top, and that will reinforce the bottom part. I'm also going to adhere these with the E6000 adhesive, so that would reinforce down here where the tabs were breaking off on these two brackets here, and then with the other piece that should reinforce the little top part which broke. I also took this plastic once I cut it out and rubbed both sides onto some sandpaper to give it a little bit more of a smoked finish to be somewhat similar to the original plastic of these brackets. So I have these screws removed. They were on the front panel, and they held in the original RCA jacks. These right here. A lot of oxidation or whatever you want to call that. But I decided to put in new jacks, and in order to do that, since these are fitted into here in a way where I didn't really want to modify this part, and I just kind of like to do things where if I wanted to reverse it and just put the originals back in for some reason, I could without having to have destroyed the original whatever this material is here. Something like almost like FRP, but it doesn't, I don't know, it doesn't really look like it. But yeah, this is just some FRP I had laying around, some blank circuit board. It did have decals on it, but what I want to do is, I took these screws, they were pretty rusty, all four of them, so I soaked them in some vinegar, and then took a toothbrush and brushed them clean, put a little acetone on them to kind of take off any oils from handling them. And I want to hit those with some black spray paint, and I'm going to put some black spray paint on these as well. So I have the inputs reinstalled. Those are the screws painted black with a matte finish paint, new RCA jacks. Both sides were replaced and done. They are now soldered in. There's the back of the plates, and mounted, connected. Next up, I got the I got my parts today. I'll go over those in a second. I'll clear the bench. But I also did repair work on these brackets. The glue, I believe, is cured well enough to have faith in its strength, and I don't think it looks too bad. I was thinking about painting them black, but not really certain if I want to go to that extent right now, but I do have faith in these. Okay, so here's my parts order from Mauser. This big box, these are the powered transistors that get mounted up on the heat sinks here. Each channel uses 2 of the same type. I ordered 4. And then up here, now this is something I wanted to talk about too, is, you know, for years now I've been ordering parts from Mauser, and I'm still making mistakes like this where you kind of take it for granted that all the specs are matching what you want, and then you get it and you're like, oh, I didn't realize that this was the smaller package. But these are the 10 ohm 1 watt, and I feel like that's a decent size in terms of what was originally in there. And this is the one that was the big one that got cooked. But then these were this 10 ohm was only half a watt, and that was on the underside of this with taking the ground for the right channel to the chassis, and that one was cooked. And these are 10 ohm, half watt, but they're the little dinky guys. And I don't know. I mean they're the same. They're the appropriate replacement, specifications. But as for the size, it just looks undermatched for what I need to use it for. But it's not, I guess, not really about the look of it, but the rating and all that. But it kind of makes you a little insecure, because if it looks so small, it just looks like that could just fail. And if you lose your ground on that, well, it have an effect on the circuit and cause all these other issues throughout the circuit when you don't have a proper ground anymore. I don't know. I could just use the 1 watt 10 ohm resistor, but then if that's not what was in the schematic and originally being used, am I risking, if this is a half a watt, this is going to give out before further damage is done. But if you put a bigger wattage resistor in there and there's an issue and it's getting heated up, but it's just not failing and breaking, it might be causing, more collateral damage. I'm not certain. I'll have to think about that. But now that I've got my parts, I'm pretty excited to start populating the board with all the new stuff. Ooh la la. These are the on semi. Let's see, it says Mexico. The 2N3773Gs. These are the powered transistors that go up on the heat sinks up here. Just wanted to take a look at them. Nice. This fancy black foam here. Nice. Wow. Alright. I want to do an update on the hot potato. I populated all my new parts onto this channel, the left channel. I got the transistors all replaced. I got the electrolytics replaced, and you can see the 10 ohm 1 watt right there. Replaced that, and there's also the 10 ohm. I made that also just the 1 watt, the same as this one up here, instead of half watt, because the half watts I got were so tiny and it just didn't look like it was going to cut the cheese. So I put the big boy underneath. I'm not going to lift that up and show that. I probably took a picture of it to show. Anyway, so I got it all populated, and then I powered it up, and I had in the fuses, I didn't have 3 amp versions, which is what it's spec'd for. I had some 1 amp fast blows, and I put that in, and sure enough, it passed sound. I was so excited. And I did my testing with this little Sony speaker. This I think it's like 30 watt max, but it's 8 ohm. And yeah, it was passing sound. It was good to go. And I checked this channel, and this side was this was supposedly working anyway. But I checked the right channel, and that was passing sound. I'm like very excited, super happy. So then I decided to start doing some tests, and that's where I discovered that on the channel with the replacement parts, the speaker output had about 90 millivolts DC voltage on it, and the original side had about 200 millivolts DC offset. And so I was a little disappointed about that, and the only way to make adjustments, there's a trim pot here. It's a 4.7K, and I dialed that fully clockwise, and that didn't change anything on those speaker outputs. And that's really for checking the bias between your power transistors, and you can check that with these 2 test points. And according to the technical, the service manual, you're supposed to have it between 8 millivolts and 13 millivolts. And when I was checking these points, I was getting about 40 millivolts. And that was with this trim pot dialed all the way clockwise. But when I turned it counterclockwise, that voltage reading only went up. and I wanted it to go down. So I started thinking, what can I do to change this? And I was like, what if I put a bigger potentiometer in here? Because with it fully clockwise, it was the full 4.7K, which in the circuit, that is right here is that trim pot. And with it fully clockwise, it was given that full 4.7K. And I'm like, well, what if I make this like a 10K pot and make it more resistance? Could I bring can I bring this number that between these test points down lower and closer to the 8 to 13 millivolt range? And I contemplated that, but I just thought, I don't know, that's not how the circuit was designed, and that might cause problems elsewhere, and I just didn't think that may have been a good idea. So I spent a good half a day, 3/4 of a day, doing a lot of research, trying to watch as many videos as I could on YouTube about DC offset coming out of speaker outputs on amplifiers, reading articles, and just staring at the schematic. And then after so much of that, I decided to try doing some readings at all the areas where they gave voltages on the schematic, and I marked those down, and a lot of them were relatively in spec, but there were a few that were out, and I circled those, and I still really wasn't certain what I could do to correct these poor readings. So I did notice, however, that in the schematic that this 8.2K, there was an addendum in the technical the service manual where it shows the board layouts that there is a revised section where they actually take the differential pair, which in the original build, it was a one package with 6 pins. It was basically 2 transistors in one package. But in the revised section, they changed it to 2 of the 2N507 transistors. And there's another change here that I kind of initially overlooked, which was this resistor was changed from an 8.2K to a 12K, a half watt. And in the circuit, it shows right here, I got a voltage reading. It's an 8.2K on both of these circuits that feeds the differential pair. And in the side where I changed it to 2 individual transistors, the 2N5087s, I still had the 8.2K, and my voltage reading, it should have been 0.65 volts. I got 0.666 volts. Anyway, at first I kind of dismissed like how that would really change anything, but then I started thinking like maybe the voltage is fine, but it's the current that 8.2K is letting through, and if I change it to a 12K, that might have an influence. So I didn't have any 12K half watt resistors on hand. Most of the stuff I have in my stock, let's see, where are we at? Resistors. Yeah, all that stuff, that's all pretty well 1/4 watt. But I did have some half watt from an error in ordering a few years ago. And I did have some different sizes, like I had 10K and 2.2K. And as you can see right here, I took and spliced them together in series, took that 8.2K out, and these together in series measured right around 12K. So I put those in, and voila. Oh my gosh, the readings were where I wanted them to be. It was like 0.9 milli, it was 9 millivolts for DC offset, and I think the test points were also, it was like bouncing between like 9, 8, 7 millivolts, which is, where is that on the schematic here? Or not schematic, but in the service manual, that was right there, right in the sweet spot. So I was like, that was it. I just need to change R706 to a 12K, just like the revision shows. So I ordered some 12Ks. Those are on order. Oh yeah, when I was doing the testing and trying to figure out what I could do, this side with all the original parts had higher DC offset on the speaker outputs, and I was putting my my multimeter leads on the emitter and base of the transistors, and their bias was actually pretty close, despite the test points being a higher number than what the service manual said it should be. The bias between, or the balance of these transistors was actually very close. So that was also confusing me, because even that really wasn't like, oh, the problem is that they're not balanced, so that's throwing things off. It's like, well, they were pretty close, so that really didn't seem to be the issue. But when I was pulling my leads off of this transistor right here, I touched them together, and I heard that 1 amp fast blow pop, and the sound went out, and it was like, ugh, uh-oh. I started testing around, and I was getting shorts all over the place, and I was like, oh, great. I just blew up all these parts in the circuit just because I crossed my leads here. I probably threw like 40-some volts or something, throughout, and cooked everything. And so I was heartbroken. I was just like in turmoil, like really a sour mood. Well, I took out this board and I started to probe around, and the only place I had a dead short was on this one driver transistor. Yeah, it was the 4218. And actually that one had been replaced. I put an X on it, but originally all the original transistors had markings on the top of them, but this one didn't, so I had assumed that this one had been replaced already once. And on the other side of the PCB, or the circuit board, with it flipped around here, there's 4218, and you can see that that's already been reworked. It looks like the solder pads got ripped up, and they had to use the leads and reach over and tap into the traces. But that transistor seemed to be shorted when I pulled this board out. The 4219 was in good working order. So when I pulled the board out and I started checking these transistors, they actually tested fine. They weren't shorted like they were when the board was in place. So I think that transistor, that driver transistor being shorted, was causing sort of some weird results when testing around here. So that's that. So where I'm at right now is I'm waiting on the order to get those 12K resistors. I did finally get some 3 amp slow blows for the fuses, as they're spec'd for 3 amps. And the next stage is I'm going to take out this board, and I'm going to replace all the transistors in here and all the electrolytic capacitors. I will do the 12K when it arrives. I also have new power transistors, and they will all be they'll be the same as this side. Yeah, that's what's next. All right, where I'm at with this project is I have pretty well most of the components on the right channel removed, and the left channel is still where I left it from replacing the transistors and electrolytics. And on the DC, I'm measuring the output, and I'm getting negative 20 millivolts. Actually, it was down to 13 and 14, and I walked away to get my phone, and it drifted up a little bit. But this has been sitting overnight, so maybe there's a little bit of a warm-up period, but that number is, I'm happy with that. And so I really do feel like this channel's fine, and haven't really gone too hog wild with the component replacement on this channel, other than the electrolytics and the transistors. But this channel, I went through and did the same replacements and tried to make it match this side, and I had some major issues, and over testing it, it seemed to just get worse, to the point where I ended up having the power rails coming out of the speaker terminals in terms of DC offset. So all the transistors I put in there, the small metal cans, they all got cooked. The capacitors were good, and the smaller plastic case transistors for the differential input and the bias were testing fine, but all the expensive transistors were toast. And the power transistors seemed to be testing fine, so I was getting negative voltage throughout the majority of the circuit, and I unfortunately just really couldn't pinpoint what happened. So I've decided to remove everything except for the 2 resistors I had bought new and put in replace to make it symmetrical with this side, and I
pulled everything else out to test. And I think what I'm going to do is just make an order through Mauser for all new resistors. And I do have more of these transistors available. I've ordered 2 of each. And then we'll put an order in for those resistors and just rebuild the circuit. So I don't know if there was just a drifting. I tested all of them, and there's only a couple of them that were out of spec, and they weren't horrible. And I don't know. I'm not certain, but with the left channel monitoring it, where are we at? Yeah, we're at negative 20, low 20 millivolts. I'm happy with that for DC offset for the speaker terminal. So I just wanted to come back and just see where that's at. I don't have the fuse on this channel, and nothing on this side's powered up. But the thing that kind of concerned me, though, when I was tinkering around with trying to get this right channel figured out, was the pre-driver transistor gets really hot. So I don't know what that's going to lead to. There's no load on it, or no signal going in either. But yesterday this got like over 100 degrees Fahrenheit, very warm. And I was kind of like, just, this one wasn't working. And I was just like, oh, this one's not working right. And as a matter of fact, what I had in there was these carbon film, maybe that's what those are called, but these beige resistors in series to get 12K. And I ordered 12K metal film and put them in both channels. And when I did that, my numbers were like, I was getting, oh look, now it's down to 17, 18. But the numbers went all up on here. It was like 30 and 40 millivolts on the DC output. I was like, what's going on? I don't know if it was because the issue on this side was throwing something off on this, but they are isolated, so that doesn't make sense. But I was just blown away that ordered 12K resistors, put one in, and then it was acting weird. And I'm like, oh gosh. And then the can was getting, this pre-driver was getting really hot, and I was just like, what's going on here? Okay, just to clarify, I had installed the 12K metal film resistor, but then after that, when the measurements were out of spec, I decided to uninstall that metal film resistor, thinking maybe that had something to do with it, and I put back in place the 2 series resistors, the 2.2K and the 10K carbon film resistors. So that's where it's at this point. It's working good with those. Okay, so here's where we're at with the hot potato. I ended up kind of taking a shotgun approach to it, and I just decided to pull out all the parts in the right channel that I felt were suspect or just potentially maybe giving me a problem, and measuring them in the circuit was just, I needed a more of a concrete result. So I decided to test them out of circuit and removed all the resistors, the one diode that was in the circuit board, and the disc capacitors, and did some testing on them. And the one, you can see I have some tape on it, but this 5.5K actually broke in my hands. No, it wasn't 5.5, it was a 3.3 ohm. And I had the capacitors already. I didn't have more power transistors, but they seem to be testing fine. So fortunately, those I didn't believe needed to be replaced. However, the transistors that are on the circuit board that are in the CAN package, like this one right here, which is the pre-driver, and then the 2 driver transistors, which are inside these heat sinks. When I tested those, I got them up here. They all got cooked. My measurements were indicating I wasn't getting direct shorts with them. However, in my little cheap tester here, when I would plug that in, they no longer were coming up as NPN transistors. They were just measuring as diodes, just one diode.
they didn't seem like they were working anymore. And the various tests seemed to indicate that these were now done. So I ordered some more of those, ordered all the resistors I would need, and then went through and then populated all of those onto the board. One difference I did do was with the CAN transistors in here. The original ones almost seemed to be like formed to this metal heatsink, and I had to use a flathead and kind of tap them to pop them out, and they weren't glued, but they seemed to have some sort of bonding to this heatsink. So what I did was on this side, unlike this side, I put a little bead of heatsink compound. I use a little bit of super lube and pushed them down through, soldered them tight to the board, and then took a Q-tip and cleaned up the excess so there wasn't globs of it in there. Another thing I did too, aside from the parts on the circuit board, the diode that was in here is the same diode that is on the power transistors. So on the power transistors, they have from the emitter to the collector on both of them a 2 amp 100 volt rated diode. That's also up here in the circuit as well. So I replaced that and also replaced these as well, along with the 0.001 microfarad disc capacitor, and that's rated at 500 volts. Now, when I pulled out the diodes, they didn't seem to be bad. There wasn't like something that made me think that they were bad. But again, I kind of, like I said, took the shotgun approach where I was like, I don't want to have to make a fourth parts order to get this amplifier working. I was already on my third order, and the shipping and handling, it was getting to me. I was getting a little crazy with it. So what I had these FR207 diodes on hand. They were 2 amp but rated at 1,000 volts. And when I put those in my little cheap tester here, some of the I got 641 millivolts. I guess that's the forward voltage, and a capacitance of 18 picofarads. And the original diode that was in circuit measured at 607 millivolts and 47 picofarads. And I was like, well, that's pretty close to this. But I wanted to get a 100 volt rated diode to match what the parts in the service manual spec'd it out for. So I ordered some from Mauser, and I don't have one here on this board, but it was a SB2H100 rated at 2 amps, 100 volts, and the specs on it were a lot different. 382 millivolts that changed just hitting the test button more than once, but it kind of drifted up but seemed to steady out around 400, and a capacitance of 150 picofarad. I'm like, wow, this is a lot different than what was originally in the circuit. And so when I pulled out the diodes that were on the power transistors, this one and this one of them looked the same, like it was the same package as what was on the circuit board, but the other one was a different package, so perhaps that had been replaced once before in the past. But when I measured those, both of those were closer to this than my brand new replacement was. And so I was kind of figuring that I want my replacement diodes to match what was in there and supposedly working, and not drastically, giving drastically different results. So I thought, even though I bought 10 of these to put in, I decided to go with these FR207s, which I had 10 of those on hand, just some random stock I had, and with those specs being more closer to what was originally in there in those locations. So in the on here, I'd get closer. Yeah, there's the FR207 there, going from negative is on the collector, positive is on the emitter, and same thing on the other transistor, negative on the collector and the positive on the emitter. So I went and replaced all that stuff, hooked it up, and it was good to go. I ran it for a couple hours yesterday, just ran music through it, and the temperatures were all even on both sides, and I felt like I had gotten where I wanted to. I did measurements on the test points and on the speaker outputs and was getting results that satisfied me. Alright, so right now I have my test leads coming out of the speaker output connected to the multimeter, and I'm measuring voltage, and I'm getting negative 8 millivolts of DC offset, and I'm okay with that. I'm stoked if it's 25 milliamps or less, and that seems to be a happy spot. Oh, let's see, it's going up, bouncing around. Okay, so I've got my test leads on the test points. We're on the right channel, and I have those connected to my multimeter, and I'm getting negative 20 millivolts. The technical, the service manual says you want it to be between 8 millivolts and 13 millivolts, and that's a little bit high. Unfortunately, though, with the trimmer pot in there, that's completely, I believe it would be, if you're looking at it from the front side, it's clockwise, so it's giving the full 4.7 kilo ohms of resistance for adjusting the bias. And the only way I can imagine I could influence that is if I added more resistance, maybe add a resistor in there to increase that to maybe, because if you lower the resistance, turning that trimmer pot so that lessens how much resistance is going through there or happening at that part, the number goes up. So if it completely turned all the way at the highest point of giving the most resistance, that's as low as I can get on the bias. So I'm not 100% if if that's going to be a modification I'm going to make immediately. This is affecting the bias of the power transistors, if I'm not mistaken. But measuring the difference between the two, they're pretty close. So okay, so I got my leads on the emitter and the base, and we're on the outside power transistor, which is this top one here. And I've got 0.534 millivolts. Now I have my test leads on the inside power transistor, which is the lower one here in the schematic, and I have 0.533 millivolts. I'm pretty happy with how close these are, so with the bias adjustment, I'm just going to sort of ride that out and see after some hours of listening with this unit, just kind of see if over time, test it again and see what differences we have. I want to move over to the left channel, see what kind of DC offset we have. Okay, I got negative 20 on there. So 20 millivolts, I'm good with that. I'm happy with that. So the other test I want to do would be the test points. Okay, so now I'm on the test points on the left channel, and I'm getting 19 millivolts. So again, kind of high as to what the specifications are looking to see, where the highest is 13 millivolts. I'm going to check the measure the base and the emitter on the power transistors on this channel next. So I'm connected to the base and the emitter of the outside power transistor, which is the top one here on the left channel, and we are getting 539 millivolts on that transistor. I want to swap the leads to the other side. Okay, I'm on the other transistor now. That is the lower one here, and that is 540 millivolts. So I'd say they're pretty close, to each other, and so I feel like that bias, even though at the test points it's a little bit higher than what that's rated for, I'm pretty happy with those numbers. I think I'm going to put some sort of documentation in this video too, showing the all the equivalents and all the replacement parts. So what I've got set up here is two of these Sony speakers, and they're hooked up with lamp cord, 18 gauge, and coming out of my headphone output on an old phone, I've got a track of drums. These speakers are, there's the info, but they're 8 ohm and they can handle up to 30 watts. But yeah, this isn't really the ideal way of making use of this amplifier, as you know, you'd want to pair it with a preamplifier, which I believe gives you a lot more control over how loud it can get. But this is just a test where I could at least just show that it's working. Oh, okay, that's good. Alright, so now I've installed the supports that keep the circuit board firmly down onto the chassis. The repairs I made are holding up, and I have screws and washers and lock nuts. But I've got those in place, no cracking. They seem to be, everything seems to be firm, no gaps. So I think the next step, I'm going to put the top cover back on. So I want to slide this on top, flip it underneath, and you put the screws in from underneath. I just wanted to show that it's got the, you can see the sort of charring there on that screen where that resistor on the left channel had just cooked and toasted. I took a rag and a little bit of, I think it was just vinegar, just damply, just try to wipe it off. But I didn't worry about taking that off completely. I kind of figured that would be like a battle scar. Okay, so I pulled out the 1 watt 10 ohm resistor and put in the half watt 10 ohm resistor, which now that is the same as it is on the schematic for this. And I'm going to put the bottom lid back on, close this thing up. Well, it's all put back together. The covers are all secured, and here's my parts bin of the things that were removed. Over here we have the components from the right channel. You know, this, go back to this note here on top from the original owner that gave this amplifier to me. Parts amp. If you repair RCA jack, which here's the original RCA jacks, and they're pretty cruddy. So I took those out and put in new ones on the left and the right. Switchboard, easy to do. And I believe what he meant by that was he actually gave me 2 of these, and the other one was functional when he gave it to me. And I believe he means by taking out the circuit board from that one and sticking it in this unit, that in terms of switchboard, easy to do because they just lift right out. And fuses, because this didn't have either fuse in it, might be the better amp. Well, no, if by changing as many components as I have, if that will still be the case. But I'm not quite the audiophile in terms of the discretion of knowing that that would be, with replacing these parts, if the sonic experience would be any less than what it could have been if none of these parts had failed and they were all still good, even being 50 plus years old. But yeah, I'm going to say this job is, I'm happy with this, and I'm looking forward to getting this set up into a stereo system with speakers and a preamplifier to go with it.
Just take this off. I'll probably fold that up and put that with the original parts that I removed from the project. Just put all that to the side.